my opportunity today to talk to Jonathan Garrett. Jonathan is the product manager at Local Motors, and his project that he's been working on for the last roughly 8 months or so is Olli, the automated trolley, or actually a shuttle bus.
Right.
And so it's electric. It's really cool. It's probably one of the very first autonomous shuttles actually out there and on the streets and running, or nearly so. We're going to find out. So, Jonathan, welcome to EV World.
Hi, thanks for having me, Bill.
It's great to talk to you. This is really an intriguing concept. I mean, I have speculated that while everybody at else is talking about Apple building a competing sort of sedan, to Tesla, an electric sedan as part of their Titan project, I have speculated that instead what they're doing is they're building a automated shuttle. And I don't know whether again, just off the top of my head, to me it sounds like that's a market that's really ripe for development and exploitation, and I mean that in a positive sense, not a negative sense. But you guys have if that's what they're doing, you've definitely beat them to the punch here with Olli. So I'd love you just chat about how this came about, and what the technology is inside of it, and where you see it going. So first of all, tell us a little bit about the origins. How did this project come about?
Sure, yeah. So we also have identified shared shuttles, as kind of a ripe space for development within transit. And it was a little earlier last year, springtime about, where we launched the Urban Mobility Challenge. Berlin 2030 was its full title.
Okay.
And the project goal was to figure out a way to move people around city centers, urban core, or even private campuses, and do it more sustainably, really. We wanted an electric vehicle that could be shared, that would reduce pollution in that area, and take more vehicles off the road. So we hosted this challenge on our website, and we had tons of submissions, and the one that ended up winning was by a young guy called Edgar Sarmiento. He's from Colombia. He submitted his design for the Berlino,
okay,
and his original design was very, very similar to what we actually ended up producing.
Ah, okay.
So it was really cool to see. I mean, he had a great concept and vision for it, and it was in line with what we were very interested in producing and what we've talked to potential customers and cities about producing. It's really filling a void in their current transit infrastructure.
Yep.
So we were excited to get started. And then we started engineering late last year. And then we went into production May of this year.
Okay.
So it's a really quick turnaround. And now we have a few proof of concepts out there driving around National Harbor, Maryland, right outside of D.C.,
right,
and Berlin, Germany as well.
Now, I'm curious, you guys are located in Phoenix. How did Berlin enter into this picture? I mean, that's a continent and an ocean away.
Right. So we were headquartered in Phoenix. It's where we originally set up shop in 2008,
right,
to produce the Rally Fighter.
Right.
But since then, we've popped up micro factories and offices in a few different cities.
Ah, okay.
So we have a place in National Harbor, like I mentioned, Knoxville, Tennessee, and then we have a small office now in Berlin, and we're looking at expanding into a full micro factory later this year.
Okay. Well, let's for people who aren't familiar with the concept of a micro factory, just sort of give us a sense of, I've been to, your typical, I've been to General Motors plants, I've been to Ford Motor plants. These are generally big, sprawling, things and that take up acres and acres and acres of ground.
Right.
What's a micro factory?
A microfactory is Local Motors' vision for producing vehicles. So we want to create a portfolio of different vehicles for different use cases and then produce them at micro factories all over the world for locally relevant use cases.
Okay.
So for instance, in Arizona, we started with the Rally Fighter. It's an off-road desert race car, street legal, but there's a lot of space and terrain to romp around in out here.
Yeah.
Somewhere like Berlin or in Maryland, the Olli would be a more locally relevant vehicle, where you have a dense urban core and in a lot more private campuses to cater to.
Right.
So,
well, I should point out to everyone that Local Motors probably came to prominence media-wise with being one of the first, if not the first, companies to digitally print an electric car using 3D printer technology. I was at the Detroit Auto Show when you had your first exhibit there, and was watching this thing painfully, slowly moving and building this car. And I'm thinking, let's see, a car company can stamp out about 1 million parts in the time it took to build this one car, right? So I'm thinking, I don't know how this is going to work out. But obviously, from a conversation I heard with Justin Fiskin yesterday, your chief strategist, the CSO, that time has come down. It was originally something like 144 hours, and now you're down to under 20, something like that?
Well, actually, our first prints that we were doing at IMTS, SEMA, and then the North American International Auto Show, like you mentioned, Detroit, those prints took us 44 hours.
44, okay.
44 hours to print, and then they spent some time on our 5-axis router, and then some more time to actually complete. So we were in for maybe 80 hours.
Okay.
Now the print itself is down to under 24.
Oh, okay.
And that's just with experimenting with software and different nozzles for extruding the material.
Right.
So it has come a long way, and now we're experimenting a lot more with different materials too, and seeing how we can really engineer those impact zones to be structurally sound, and then wrapping materials with other composites. So there's just a lot more still to discover, really.
Right.
We started with an ABS carbon fiber composite, and we've used that material on a lot of our prototypes, and it's kind of to exhibit the first degree use of 3D printing, which is right from the printer direct onto the vehicle.
Right.
The other cool thing that we've done a lot of is created tooling. So we can print molds, and then we can thermoform different materials over them.
Okay.
So we're making interior pieces for vehicles. We can make exterior pieces too. It really just depends on what you need to form. There's a lot of different options.
Right. Well, the first vehicle we saw was this thing that had this, very sort of rough exterior where you could actually see the milling lines and things like that. And then subsequently, though, you've come up with a way to actually smooth that out, so you've got a more sort of conventional looking exterior body.
Yeah, I think at first it's cool to see the layers, so you really understand what you're looking at, and you can visualize how the extruder goes back and forth and builds. But then you can finish it, so you have a smooth exterior, and you can paint it, you can vinyl wrap it. Really anything that you would do to a piece of sheet metal can be done to this material as well in terms of finishing it for aesthetics.
Right.
Yeah.
So let's get back to Olli then. How much of that technology that was in these cars that you've built now, how much of that has transferred to the Olli project?
We use direct digital manufacturing quite a bit to create the structure. It does use an aluminum welded chassis.
Okay.
But then the body panels and most of the interior is formed by DDM processes. So some of those pieces are first degree. We actually have raw 3D printed components on the vehicle: the fender wells, rocker panels, a lot of bracketry, the seat structures. Those are all first degree. And then we created tooling to create the seats, the interior panels, the interior roof. So those were all created from 3D printed molds that we make in-house.
All right. So, and we'll obviously have a picture of what Olli looks like. So let's talk about the because obviously EV World's interested in the electric side of this. This is an entirely electric vehicle. So how did that integrate into that design? I mean, was that something you guys did, or did you bring in another engineering entity to help with that? Tell us a little bit about that.
Well, the vehicle was always concepted to be electric, and that's a pretty large undertaking. So we did partner with a company in Germany to help us out with that, and they designed a battery pack and a BMS specifically for Olli, and we've been working with them ever since now for about a year. So it sounds like then that actually the chassis, I mean the drive system, sounds like that actually predated the development of the overall structure of the vehicle, or did they sort of coincide? I think they started happening at about the same time. It was late last year. When they really started the engineering. On both ends, yeah.
And then, of course, this obviously has autonomous features in it. So I think you had to bring in, NXP, I believe, was, or something like that, was the company with the autonomous technology. And then, of course, you partnered with IBM and Watson. The AI system is integrated into this.
Yeah, so we've been working with NXP on a few different projects. They've provided us with some of the hardware. But the company behind the actual drive of the vehicle, the automation software, is a company called Meridian Autonomous. And they have been integral every step of the way to helping us design the sensor layout and then actually designing the software layers needed to operate the vehicle safely. So that's been our main partner there. And then working with IBM on the cognitive computing platform, kind of the user interface. So what you experience when you're on board.
All right. So it's like walking onto the Starship Enterprise's command deck and you talk to the computer. Does it talk back to you?
Yeah. So we've got the mic hooked up to an iPad right now, an iPad Pro. And it's got the speakers so you can hear throughout the vehicle. And you can speak to Olli. You can tap on the screen to communicate with Olli.
Okay. All right. Yeah. So what's the getting back to the EV side of this thing for a moment, what's sort of the operational specs on this? You've got, this was engineered to go 20 miles, 50 miles, 200 miles.
Yeah, right now our lithium-ion battery pack will go about 30 to 50 miles on a full charge. And we obviously want to extend that, and we also want to look into inductive charge with supercapacitors too. So that's one of the areas we're currently exploring. But right now we're using an 18.5 kilowatt hour lithium-ion battery pack, and I think the motor is about a 20 to 30 kilowatt motor.
But of course, and since it's a shuttle, it doesn't have to hit freeway speeds. It's just safely moving downtown, 20 miles an hour, maybe 25?
Yeah. This vehicle is intended for low-speed use, so under 25. An average will probably be around 15, more realistically.
So you're gonna. I've got a smartphone with me. Apparently, I will need an app. I would imagine to call Olli up, let them know, hey, I'm here at the corner of something and something. And I need to go to point B. Talk a little bit about that aspect.
Yeah, we have a few different modes of operation. So we can do fixed route, where you basically have a circulator shuttle type use case, and it'll stop at fixed waypoints. But we can also do on demand. And so that would involve you using an app, and you would call up the vehicle. There could be two scenarios. You could have to then summon it to a fixed waypoint, or it could just pick you up exactly where you are. And then you would put in your destination, and then it would optimize that route. If you're not talking about a fixed route, it would find the best way to get to your destination. And since it is a shared vehicle, it would optimize in real time and find other people traveling along your same route along the way with you.
Okay.
They may be dropped off first, they may be dropped off afterwards.
Right.
But that's the concept.
So it's sort of like if I take an airport shuttle, the driver wants to know, well, which hotel are you going to? And then he tries to mentally optimize, who do I drop off first? Who do I drop off last, kind of a thing. Except this
Right.
case, is this being done by Watson or is this other software?
This currently could be done by Watson. We're actually working with a couple companies to do the fleet management.
Okay.
So I think we will use different companies depending on our operating environment,
Right.
Or even what country we're in.
Right. Which of those scenarios is the most attractive to the people you've talked to up to this point? And from what Justin was saying, you've got quite a few pre-orders here already.
We do, yeah. So we're working with a lot of cities and transit operators. They're very interested in augmenting their current transportation networks, and they want to reduce parking around transportation hubs. Right. So really on-demand service is kind of the pinnacle. That's what everyone wants to get to.
Right.
It's, of course, a little more complicated than just operating a circulator type route.
Right.
But really, that's our goal, and that's where we're headed. So we want to be able to, in real time, give people on-demand transportation within kind of a fixed area. There will be boundaries because we're only operating at low speeds. But to be able to serve an entire area in an on-demand fashion is where we're headed.
Yeah. So let's talk about the sort of the autonomous side of this thing. I gather you're using probably what? Cameras, LiDAR, GPS.
Mm-hmm.
How quickly does it take one of these to learn where it's at and start service?
So our process that we're using is we will first LiDAR map an area.
Okay.
So the vehicle has an embedded map of its operational area.
Okay.
And that's stored on board for reference.
All right.
And then the sensors that it uses to do object detection and localization in real time are LiDAR, radar, ultrasonic. We're not currently using ultrasonic, but we do plan on implementing, and then stereo cameras.
Okay.
So between those redundant sensors, the vehicle is able to localize itself and detect objects in real time and kind of cross-reference that with the embedded map.
Okay.